Hey, hello friends, welcome to my channel. In this Azure DevOps tutorial series, today let's discuss about Git workflow. Okay, so Git is a very important concept for any developer. Okay, so especially in Azure DevOps, like the use of version control is very much important. Even in our previous video, we discussed about how we use Git in repos. Okay, so in this particular video, we'll discuss in detail about why do we really need Git, right? So we will begin by explaining some background on version control tools. Then we'll move on to how to get Git running on your system, and finally how to get it set up to start working with. Okay, at the end of this video, you should understand why Git is around and why should you use it, and you should be all set up to do so. All right. So first, we'll try to understand what is version control. Okay, so if you have to really understand why Git is in place, you should actually understand the concept called version control. Okay, so if I have to explain this to a layman, version control means like you need to track the different versions of your files or any basically I can say files. Okay, so if you are a programmer or a developer who are working in real time, so you might be writing a lot of codes, right? So managing all those code is going to be very difficult task. Okay, so if you are working on even if you are working on a very smaller project, it is very difficult. But in case if you are working on a multiple team member project, believe me, maintaining version control is a very tedious task. Okay, so let's try to understand what is version control. Why should you care? Version control is a system that records changes to a file or a set of files over time so that you can recall specific versions later. Okay, so the reason you want to maintain version control is because in case if something goes wrong, or else if you want to revert back to a previous version because business has made the decision to go back. So in those kind of situations, like you can easily switch back to specific versions at the later point of time. Okay, so say let's take an example. Okay, if you are a graphic or a web designer and want to keep every version of an image or layout, a version control is a very wise thing to use. Okay, it always allows you to revert selected files back to the previous state, revert the entire project back to the previous state, compare changes over time, see who modified it last, and what might be and what is the problem that is currently occurring, who introduced an issue, and many more. Okay, so using a version control system, it also generally means if you screw anything in your real-time projects, right, you can easily recover using this version control. Okay, so let's try to understand few version control systems back in history. Okay, so that you will have a very clear picture of how this Git came and why this distributed version control system is very important. Okay, so first we'll look at local version control systems. Okay, right. So what is a local version control system is like, imagine our old days, like how we used to save our files. Like in case if we have to prepare multiple versions, all we do is like we might have a folder and we might save the files in a different names or versions, whatever we wanna call it. Okay, so many people's version control method of choice is to copy the files into another directory. This approach is very common because it is so simple, but it is also error prone. Okay, it is easy to forget which directory you are in and accidentally write to the wrong file or copy over files which you do not actually mean to. Okay, so to deal with this, programmers long ago developed this local version control systems that had a simple database that kept all the changes to the files under revision control. Right, if you look at this particular diagram, like you can see here we have a file, but here we have a version database, like, and then we have different versions tracked here as well. Okay, so we have version 1, version 2, version 3. You can imagine a simple database or a folder or kind of thing, which will easily make you understand how local version control system begins. Okay, so one of the most popular version control tools was a system called RCS, like which is still distributed with many computers today. RCS was, it works by keeping the patch sets in a special format on disk, and it can then recreate what any file look like at any point of time by adding up all the patches. Okay, so it worked in it worked by keeping different patch sets. Okay, so this is how generally local version control worked. Okay, so in order to overcome the problem with this local version control system, next came the centralized version control system. Okay, so the next major issue that people encountered is that they need to collaborate with developers on other systems. Okay, so with the problem with local system is you can deal with only one computer, like your own computer, and there is no option to collaborate with other computers. Okay, so whereas this centralized version control system actually solves that problem. Okay, what centralized version did is it helped you to deal with the problem which had local version where we were not able to collaborate with other developers or other systems. Okay, so if you look at this particular diagram, like we have two computers here, like computer A and computer B. We had different files and we had a centralized server, okay, where you tracked all the version. Like say you have a centralized version and you have like a 5 to 10 member team. All the 10 member in your project can access that centralized server, and you can keep track of all the versions in the server. Okay, so this is how centralized server worked. Okay, however, this setup also has very some serious downsides. Okay, the most obvious is the single point of failure that the centralized server represents. For example, if the server goes down, for an hour, then during that hour nobody can collaborate at all, and or at all or save version changes to anything they are working on. Okay, if the hard disk in the central database is on become it if it becomes corrupted, and if there are no proper backups, you lose absolutely everything, the entire history of the project, except whatever single snapshot people happen to have on their local machines. Okay, so that is the major drawback with this centralized version control system has. Okay, so in order to solve this, okay, in order to solve the problem with the centralized version control system, then came the distributed version control system. Okay, so what the distributed version control system does is, like, Git is a distributed version control system. There are a lot of other tools available in the market too, but Git is the most popular one. Okay, so in distributed version control system, clients don't check out the latest snapshot of the files, rather they fully mirror the repository including its full history. Okay, thus if any server dies and these systems were collaborating via that server, any of the client repositories can be copied back to server to restore it. Every clone is really full backup of the data. Okay, you can see how distributed version control works here. So here we have a server, and here we have multiple computers. Okay, so let's try to show you an example later at the end of this video, so that you'll have a very clear picture about how Git uses this distributed version control system. Okay, so right, next we'll try to understand the Git architecture. Okay, so it's really important for you to understand how the Git architecture is. Okay, so here in this diagram you can see we have two different categories, like one is local and another one is remote. So local means whatever you're dealing with in your local machine is what we call local, and whatever is in the website or on the cloud or in the internet is what you generally call as remote. Okay, so in the local we have three areas, like one is working directory, one is staging area, and another one is local repo. Okay, so we have a lot of commands that we need to use with Git. Okay, I'll show you a few basic commands going forward at the end of this video, whereas we'll try to look at very basic commands here, like one is git add, git commit, git push, git pull, git checkout, git merge. You can see what happens at each stage. So whenever you so working directory is the local space that I am using. Okay, so say I've cloned a folder in my local machine and I'm having that folder, so that is what we generally call as working directory. Okay, so now you make changes, you add a code or you update a code, you make any changes to your working directory, and then you issue a git add command. It will go and sit in your staging area. Okay, staging area is an area which internally works with Git, Okay, so within the staging area, once after that staging area, once you commit it, okay, once you commit it, it will go and sit in your local repo. Okay, then you have to push it to the remote repository. So until this stage it is present only in your local machine, whereas now if you issued the git push command, it will go and sit in your remote. Okay, so do not worry, I will show the an example, and I will try to recollect all these points at later so that you will have a very clear understanding. Okay, so as I said in the diagram, like this is the this is just a descriptive way of showing you these stages that we have and that I showed in the previous slide. Okay, so first one is working directory, staging area, local repository. And if I have to read through this description, like this is created when a git project is initialized onto your local machine and allows you to edit the source code which is copied. Next one is the staging area. Post the edits, the code is staged in the staging area by applying the command git add. Okay, so in our previous slide we saw once we issued the git add command, it will come and sit in your staging area. This displays a preview for the next stage. In case further modifications are made in the working directory, the snapshots for these two layers will be different. However, these can be synced by using the same git add command. Alright, finally we have local repository. If no further edits are required to be done, then you can go ahead and apply the git commit command, which will actually this will replicate the latest snapshot in all the three stages and make them in sync with each other. Okay, so now let's see the use of the role of git in DevOps. Okay, so since now you might be wondering, like, all of a sudden why I have included a separate video for git in the DevOps Azure DevOps tutorial, right? The reason is because the role of git in DevOps is really very much important. Okay, it plays a very vital role. DevOps is responsible for the development and operation process of softwares. It allows non-linear workflows in a distributed manner by providing data assurance to create quality software. Okay, this tool offers a space for developers to work. Git allows developers to collaborate, make it easy for them to visualize the work, saving a lot of time and effort. Further, Git helps in code management that can be pushed to the shared repository, making the code ready to be integrated, tested, and deployed. Okay, so this is little theoretical. So I will I the reason I have put this slide is because I want you to understand the role of git in DevOps. Okay, so believe me, git is really very much helpful in real-time development. You can ask any developer. I would definitely promise, without version control, the code will be very messy, and there is a huge chance that you will lose track of a lot of the code in the in real-time projects. Okay, so finally I have a couple of slides to make you understand what are popular git commands. Okay, so I will maybe I will leave this slide for a second. You can pause pause the screen, and you can look at maybe you can read through all these commands one by one. Do not worry, I will show you the basic commands that we will be regularly using in our day-to-day life. There are few other advanced command as well, which I have not covered here, like git stash and all. It is really it's I don't want to give all that information for a very basic level video. Okay, so I have just given some basic comments which will put you in a better way to understand how git works in real time. All right, so now let's go to the real practical session. Okay, so in my previous video I have created a basic repo, and project online DevOps demo is the repo which I have created, and I have pushed very first code here. All right, so in order to make you understand how git works, let's try to add another new file to this particular repo as well. Okay, first thing what you need to do is, there are a lot of ways in which you can use git, like you can use git UI. Few people even use an ID like Visual Studio and Visual Studio Code to actually push your code to git. But in order for you to make it in order for you to make it very basic, I will start using git bash so that it will give you a very detailed view of how git works. The first thing you need to do is, like, if you have to work, say I'm a developer, I walk in to office tomorrow, and I want to pick up where the project team has left off. Okay, so generally what I do is, like, whenever I walk into office, the first thing I do is, like, I will do a pull if I am maintaining it regularly, or else I would do a fresh clone. Okay, so I'm gonna clone this particular project. Okay, so I'm gonna clone this. And before cloning this, I want to save this in a local directory, right? So I will create a folder. So let me call this as git demo. Okay, so I have a local folder created. Now I need to go into this git demo folder. So let me go into git demo. Here it is. So I'm now into this local folder. Next I need to clone this, right? So I will issue a git clone, and I will provide the URL. So now the cloning has started. It will take a second. So now my cloning is done, right? And then I need to go into that project folder. So as soon as I enter into the project folder, you can see it went into my main branch. Okay, I will try to make a separate video about branches, but for now we'll just stick to very basic stuff. All right. So here now I am into main branch. Okay, so now if I go into the folder, local folder, you can see initially this folder was not present. Now since I have cloned, a folder called project online DevOps demo is now cloned into my local. All right, so next what I'm planning to do is, I'm planning to add a new file. All right, okay, maybe I have written a lot of, I have saved a lot of files. I have written a lot of codes in the past for demo purposes. Let me copy anything. Like for now, I am just picking compare to list. Okay, do not worry about the meaning of the code. Like, all I need to make you understand is how the Git work. So I am adding a new code here. Say, let me. I have added a new code called compare to list. So this is basically a new Python file. So since I will go into git checkout -b. Generally we have to create a new branch. If I have to main branch is the key branch that it is the remote branch that everyone of your team will be looking at, whereas each and every developer will create their own branch for their development work. So git checkout -b, let me call it as a branch 1 for now. Okay, now I have switched to branch 1. So now if I issue git status, you can see there is a new file that is added, which is highlighted in red color, which is compare to list. Okay, so this is the new file that we have added, right? So once I have issued that git status command, so at any point of time, like if you issue this git status command, you can see what is the current status, right? So current status for me is, like, I have added a new file. Now I have just created a new file, but I have not added it anywhere. Okay, so now what I'm gonna do is, I'm gonna add this git add space dot. So generally space dot means I will add all the files. Okay, so if you want to add any specific files, generally what you can do is, you can issue git add and that file name here. Okay, file name. But generally, as a best practice, I would generally add git add space dot, which will actually copy all the files where you have made the changes. Git add dot. So now it is done. So now let me switch back to the diagram here, right? So if you look at this diagram, so now I have issued this git add command. This is my local working directory. Okay, working directory is the actual folder that we have created. Okay, so this is my working directory. From the working directory, so once I have added this git add command, it is now sitting in the staging location, right? So next step is to issue this git commit. Okay, so now I have added, I need to commit it to push it into the local repo. So now git commit -m, I need to provide any basic meaningful message, whatever is readable for you. You can use that comment here. Like for here I will tell added compare to lists code. Okay, so I'm just giving some meaningful comment here. Once that is done, now the git commit is done. Okay, so now if I look back to this diagram, so now git commit I have issued, now it is sitting in the local repo, but I need to do a git push, right? So next step is git push origin. So one thing to remember is, if you look at these previous comments, I have not used this keyword called origin anywhere. The reason I have to use this origin is because if I am trying to push anything into remote repository, if you generally working with remote repository, you have to use this keyword origin. Okay, so that is a key point to remember. So then I have to put this branch, so I am trying to push it to my branch only. Okay, so git push origin branch 1. So once this is done, now let me go to my repo. So this is what we call as remote. So in our slide we showed you two categories, right? One is local and one is repo. Local is whatever we were doing in our local machine. This is what we call it as remote. Okay, so now if I refresh this, you can see I've got a new notification telling I updated branch 1 5 minutes ago. All right, so now if I look back at the slide, so now git push is done. Now it is sitting in your remote repository. Okay, so that's all, your single workflow is done. Where else, if you have to say if I'm working in tomorrow, okay, if I'm working in tomorrow and I have to start working on a new code development or any work that I've been doing, so what you generally do is you do a git pull, because you might not have the code changes which others have done. Okay, your local repository will not be up to date because you might not have code that is developed by other people. Okay, so in order for you to keep your repository updated, you need to use this git pull command in real time. Okay, so so now let me go back here. Sorry, here. So now you can see I need to create a PR. So we have this concept called PR, pull request. The reason is because if you are working on a larger project, this main folder is a main branch is a very sensitive area. So generally not everyone will have access to this main folder. Only like admin or any project leaders will have access to that main branch, who will review your code and push it to the main branch. So as a developer, I will he or she can only make changes to their own branches, right? So now I have made changes to branch 1 and I'm creating a PR. The reason I have to create PR is to make my people notify, make my admin or my project lead notify that, hey, I have done this change, like can you review this and push this code into main branch. Okay, so you can see I am trying to push this from my branch 1, which is my developer branch, into main branch, right? You can view the changes as well, files, commits, there are a lot of other informations here too. Okay, so I can give a title, I can add any detailed description if required, and I can also add reviewers. You can check if you are enrolled into a project, the reviewers details will be shown here. You can add the mandatory reviewers and optional reviewers too, and each and every work that you are doing will be linked to a work item, so you can link an work item and create a tag. So now there are a couple of options. One is to create and another one is to create as draft. Create means you can create it and right away your PR will be, that is your pull request will be active, whereas create as draft will not make your PR active. The reason is because whenever you are working in real time, generally this Azure DevOps will be integrated with the pipeline. Like there's a concept called pipeline, which I will cover in our upcoming videos. So whenever you are working in pipelines, right, so it is a best practice to actually test how your code is working by creating a draft PR. Okay, so now I have all set, so I'm just clicking on create. So now I can see the PR is now active. All right, now my PR is active. So I have created this PR to push the code from branch 1 into main. So currently I have no merge conflict. And then I can add all other details here. Like you can see, these and all are few mandatory and optional details which you can add according to your project requirements. All these are very user friendly fields, you can easily understand and start assigning it. Okay, finally all you need to do is, if I am a admin or a project lead, what I would do is I can review and approve this pull request by providing this details here. I can approve it with suggestions. I can wait for author, and because I might have some queries. If I'm not happy with the code that I have written, the admin or project lead can reject this PR too. Okay, finally you can, once this is done, okay, once the approval is done, you can complete this PR. So once this is complete, okay, once I complete merge, you can see this. What will happen generally is your branch 1 will be deleted automatically, that is your developer branch will be deleted, and the code will be merged into main branch. Okay, so here it is. So you can see the PR is now completed. Now if you go back to your main branch, let me click on the main branch here. You can see the new code is now added, the compare to list Python file what are we added here, right? So this is now added and available in your main branch. You can see the other branches, the local developer branches whatever we created is deleted. Okay, so this is how you can push code. This is how you can get started with Git and push your code from local to remote. Okay, so now I hope you understood how the Git architecture works. I think this is more than enough for you to get started with Git. Okay, so if you know this command, trust me, this is more than enough for you to work in a real-time project. But there are few advanced concepts as well. Since this is a beginner level video, I am not gonna cover all those things. Let's try to make a separate video to understand how to resolve a merge conflict. Now what are a few other Git commands that we have. Okay, those kind of things we will try to learn it in a separate video. Okay, for now I hope everyone understand how Git works. Okay, and I would suggest you to try this on your own and try to push your first code into your Git repo. All right, so I hope you like this video, guys. If you like this video, please like, share and subscribe it with your friends, and if you really like this video, please subscribe to my channel. Thank you.